for these problems, on number 10, there's a pop fly, and I always have foreign exchange students that don't know. Do you know what a pop fly is? Okay, in baseball, do you know what baseball is? Yes, there we go, right? In baseball, pop fly is a ball that's hit straight up, right? So when the batter hits it, it's an easy out because the ball goes straight up and the catcher just catches it, yeah? Okay, so anyway, in this one, a pop fly is going 34 meters per second. And the question is, how high will it go? Class. Shut up. Can we focus a little bit? Just a little bit more. Matthew, Jacob. Thank you. Okay. So what do you suppose it's got here? Probably kinetic, and at the top does it have kinetic energy? No, because if it's got kinetic energy, it's not at the top, is it? Right? Yeah? So that's not too bad, right? You've got KE turns to PE, right? 11 says a 1 kilogram ball falls 20 meters. What is its speed when it hits the ground? Well, here it is. Isn't this exactly the opposite of this one? That's like the brilliance of this, right? So here, what do we have to begin with? Potential, and at the bottom we have kinetic. That's a 1-to-1. I call these things 1-to-1s, right? So potential turning into kinetic energy. 12 says a car is going some speed at the bottom of a 5-meter tall hill. How fast is it going at the top? So it's rolling up the hill. Doesn't really matter, right? But it's a 5-meter tall hill. Here it is moving along, right? And it's going apparently 12 meters per second. So the question is, how fast is it going at the top? Right? We've solved those before, haven't we? It's what turning into what and what. At the bottom it has kinetic, and at the top it has potential and kinetic. And what's your clue that it has kinetic at the top? You're looking for its velocity. If it wasn't moving, that would be kind of a stupid question, right? Okay. So this one is KE turning into KE plus PE, right? What's 13? A roller coaster is going at the top of a 7.5 meter tall hill. So this one's a hill to hill, right? So it's here it is, right? So here it is 5 meters per second here. This hill is 7.5 meters tall. This hill here is 5 meters tall. Yeah? What's its speed there? It's going to be going faster, right? Isn't this just like the one we just did, just like this one? Yeah? It's what turning into what? Yeah, you can, it certainly has kinetic as well at the beginning, right? Because it's moving, right? So it's kinetic and potential turning into, and then you can argue about this, right? You can either say it's got kinetic and potential, or you can say the hill is 2.5 meters tall and it has only kinetic, right? Whatever you like. I'll never force you one way or the other. Okay, and then this one is the opposite of this, right? It's at the top of a, right here it's at the top of a 3 meter tall hill, a 7 meter tall hill, and it's going 12 meters per second. Apparently that's a very common velocity for things to have, right? What's its velocity there, right? Is that right? And then 15, it just rolls down a hill, right? I call these roller coaster problems. They're very common. It's like, shh. Like this. So here's our roller coaster car. It's going 5 meters per second. I'll bet it's going faster down there, yeah? So that's the trick, is to draw the picture. It helps, I think, to draw pictures. I think it helps. I mean, if you can draw the picture, I think you can solve the problem, can't you? I'm thinking. Go ahead and just work on those, and what you get done, you don't.